Yes, there is a maximum size subpanel that can be installed on a 100 amp service. The National Electrical Code, specifically Article 408.3, addresses this. This article essentially limits the sum of the ampere ratings of the overcurrent devices connected to a subpanel, ensuring that it does not exceed the rated capacity of the panel itself. This is a crucial safety measure to prevent overloading and potential hazards. Furthermore, 408.3 dictates that the total load supplied by a panel board should not exceed 80% of its rated capacity. This 80% rule is a vital aspect of electrical safety and efficient system design. To understand the implications of these code requirements, let's delve into the details. Firstly, consider the rated capacity of your main service panel, which in this case is 100 amps. This 100 amp rating represents the maximum amount of current that the service can safely deliver. Secondly, when installing a subpanel, you must ensure that the total sum of the breakers installed within the subpanel does not exceed the ampere rating of the subpanel itself. For example, if you have a subpanel rated for 60 amps, the combined ratings of all the individual breakers in that subpanel cannot exceed 60 amps. Thirdly, the 80% rule comes into play to prevent continuous overloading. This rule stipulates that the total continuous load on a panel board should not exceed 80% of its rating. A continuous load is defined as a load that operates for 3 hours or more at a time. For instance, if a panel board is rated for 100 amps, the continuous load connected to it should not exceed 80 amps. This translates to 100 amps multiplied by 0.80, which equals 80 amps. Applying this to the subpanel scenario, if you have a 60 amp subpanel, the continuous load on that subpanel should not exceed 48 amps, calculated as 60 amps multiplied by 0.80. To determine the appropriate size of a subpanel for a 100 amp service, you need to carefully calculate the loads that will be connected to it. This involves identifying all the appliances, devices, and equipment that will be powered by the subpanel and determining their respective amperage requirements. Once you have a comprehensive list of the loads, you can calculate the total load and ensure that it does not exceed the subpanel's rating or the 80% continuous load limit. Consider a scenario where you are adding a subpanel to power a workshop. In this workshop, you anticipate using various tools and equipment, including a table saw, a drill press, a grinder, and lighting. Each of these items will draw a certain amount of current, and it is crucial to accurately determine these values. Let's assume the table saw draws 15 amps, the drill press draws 10 amps, the grinder draws 5 amps, and the lighting consists of 10 100-watt bulbs on a 120-volt circuit, which equates to approximately 8.3 amps. The total connected load for these items would be 15 amps plus 10 amps plus 5 amps plus 8.3 amps, equaling 38.3 amps. Now, consider if some of these loads are continuous. For example, the lighting may be on for more than 3 hours at a time. In that case, the lighting load must be considered continuous, and the 80% rule applies. To account for this, you must ensure that the total continuous load does not exceed 80% of the subpanel's rating. If you plan to use the table saw, drill press, and grinder simultaneously for extended periods, these loads would also be considered continuous. In such a case, the total continuous load would be 38.3 amps. To comply with the 80% rule, the subpanel's rating must be at least 38.3 amps divided by 0.80, which equals 47.9 amps. Therefore, you would need a subpanel rated for at least 50 amps to accommodate these loads while adhering to the 80% rule. It is important to note that these calculations are simplified examples, and it is crucial to consult with a qualified electrician to accurately assess the load requirements and ensure compliance with all applicable codes and regulations. In addition to NEC Article 408.3, other relevant code articles may apply depending on the specific installation and location. These may include articles related to overcurrent protection, grounding, and wiring methods. Consulting the latest edition of the NEC and seeking guidance from a qualified electrician are essential steps in ensuring a safe and compliant electrical installation. When selecting a subpanel, it is also important to consider factors such as the available space, the number of circuits required, and the future expansion needs. Choosing a subpanel with sufficient capacity and features will ensure that the electrical system can meet the current and future demands of the connected loads. Furthermore, proper installation techniques are crucial for the safe and reliable operation of the subpanel. This includes ensuring that all connections are tight and secure, that the wiring is properly sized and insulated, and that the subpanel is properly grounded. It is also essential to label all circuits clearly and accurately to facilitate future maintenance and troubleshooting. In summary, determining the maximum size subpanel for a 100 amp service involves a careful consideration of NEC Article 408.3, the 80% rule, and the specific load requirements of the connected equipment. Accurate load calculations, proper subpanel selection, and adherence to all applicable codes and regulations are essential for ensuring a safe and compliant electrical installation. Consulting with a qualified electrician is highly recommended to ensure that the installation meets all requirements and operates safely and reliably. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. Attempting electrical work without the necessary knowledge and experience can result in serious injury or property damage. Therefore, prioritize safety and seek expert guidance when dealing with electrical installations. The NEC is a comprehensive set of standards that governs electrical installations. Understanding the NEC is crucial for ensuring safety and compliance. Article 408 specifically focuses on switchboards, switchgear, and panel boards. These are essential components of any electrical distribution system. Panel boards, as discussed, are distribution points that receive power from the service equipment and distribute it to various branch circuits. The NEC provides detailed requirements for the construction, installation, and protection of panel boards to ensure their safe and reliable operation. One key aspect of panel board design is the overcurrent protection. Overcurrent devices, such as circuit breakers and fuses, are designed to protect circuits from excessive current, which can lead to overheating, insulation damage, and even fires. The NEC specifies the types and ratings of overcurrent devices that must be used in panel boards to provide adequate protection. Another important consideration is the grounding of panel boards. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip over current devices and prevent electrical shock hazards. The NEC provides detailed requirements for grounding panel boards to ensure that they are properly connected to the grounding system. In addition to the general requirements for panel boards, the NEC also includes specific requirements for different types of panel boards, such as lighting and appliance branch circuit panel boards and power panel boards. These requirements address the unique characteristics and applications of each type of panel board. When installing a subpanel, it is essential to follow all applicable NEC requirements to ensure a safe and compliant installation. This includes selecting the appropriate size and type of subpanel, providing adequate overcurrent protection, properly grounding the subpanel, and labeling all circuits clearly and accurately. Consulting with a qualified electrician is highly recommended to ensure that the installation meets all requirements and operates safely and reliably. The 80% rule, as mentioned earlier, is a critical aspect of panel board loading. This rule is intended to prevent continuous overloading of the panel board, which can lead to overheating and premature failure. The NEC defines a continuous load as a load that operates for 3 hours or more at a time. When calculating the load on a panel board, it is essential to identify all continuous loads and ensure that the total continuous load does not exceed 80% of the panel board's rating. For example, if a panel board is rated for 200 amps, the total continuous load on that panel board should not exceed 160 amps. This translates to 200 amps multiplied by 0.80, which equals 160 amps. To comply with the 80% rule, it may be necessary to increase the size of the panel board or to redistribute the loads among multiple panel boards. It is also important to consider the potential for future load growth when sizing a panel board. Choosing a panel board with sufficient capacity will ensure that the electrical system can meet the current and future demands of the connected loads. In addition to the 80% rule, The NEC also includes requirements for dirting conductors based on the ambient temperature and the number of current-carrying conductors in a raceway or cable. Dirting reduces the ampacity of conductors to account for the effects of heat, which can degrade the insulation and reduce the conductor's ability to carry current safely. When sizing conductors for a subpanel, it is essential to consider the dirting factors and ensure that the conductors are adequately sized to carry the intended load. The NEC provides tables and formulas for calculating the dirting factors based on the specific conditions of the installation. Understanding these requirements is crucial for ensuring a safe and reliable electrical system. Furthermore, it is important to be aware of any local amendments or interpretations of the NEC that may apply in your jurisdiction. Local authorities may have specific requirements that supplement or modify the NEC. Consulting with local building officials or a qualified electrician can help to ensure that the installation complies with all applicable codes and regulations. Electrical codes and standards are constantly evolving to reflect advancements in technology and to address emerging safety concerns. Staying up to date with the latest edition of the NEC and other relevant standards is essential for ensuring a safe and compliant electrical system. Participating in continuing education courses and attending industry events can help to stay informed about the latest developments in electrical codes and standards. In conclusion, determining the maximum size subpanel for a 100 amp service requires a thorough understanding of NEC Article 408.3, the 80% rule, conductor dirting, and other relevant code requirements. Accurate load calculations, proper subpanel selection, and adherence to all applicable codes and regulations are essential for ensuring a safe and compliant electrical installation. Consulting with a qualified electrician is highly recommended to ensure that the installation meets all requirements and operates safely and reliably. Remember that electrical work can be dangerous, and it is always best to leave it to the professionals. Attempting electrical work without the necessary knowledge and experience can result in serious injury or property damage. Therefore, prioritize safety and seek expert guidance when dealing with electrical installations.